This is November 2015, Standard Level Paper 2, question 4, and it's a question about sequences. So we're given three terms of sequence and we're told it's geometric. So how do I find what the value of r is? Well, I can either divide the second term by the first, or I can divide the third term by the second. It shouldn't matter. So I'm going to do 1.6 divided by 0.64, and if I do that I get the answer 2.5. And I think given that these were given in decimals, I'm going to stick to working in decimals. It's a good rule of thumb. If they were given in fractions, I'd be working in fractions now. That's part A. Find the value of r. And the marks was just allocated one method mark for a correct division and one accuracy mark for the number 2.5, or equivalent. Part B. We are evaluating S6. S6, the formula, make sure you pick the right formula out. This is a geometric sequence. So the formula for that is U1 r to the n minus 1 over r minus 1. Or you can use the version with 1 minus r to the n over 1 minus r. That will usually give you negative values. So I'll stick to using this one, which I think people generally find more comfortable. And we know all the variables we need in order to be able to evaluate that. We know n is 6. We know u1, just scrolled away from it, but we know u1 is 0.64. And we've just worked out r is 2.5. So it's just a case of rewriting that. S6 is equal to 0.64 times 2.5 to the 6 minus 1 all over 2.5 minus 1, which you can just stick in your calculator to evaluate it. You can stick it in exactly as it's written, and that's what I recommend you do. You might want to evaluate the bottom in your head to save you having to use some brackets. Obviously, the denominator there is 1.5. If you do that, you get the answer 103.74. Or if you prefer to keep working to 3 sig figs, which is the guidance we're generally given, you can give your answer as 104. Marks there were allocated, 1 for using the formula and 1 for getting the answer. Part C, find the least value of n such that Sn is bigger than 7,500. There's two ways to do this. There's the sort of maths, algebraic way, which in a certain sense is more appealing. But, given that this is a calculator paper, given that time can be a factor, the more sensible thing to do is to do it in using a table of values. So, we're supposed to be considering Sn. And we know the formula for Sn is U1 0.64 times r 2.5 to the n minus 1 all over, and I'm going to evaluate it, all over 1.5 in this case. So the sensible thing to do is to stick that into your calculator. And that will look something like that. The only real difference is I've replaced the x to the n with an n. I've replaced an n with an x. And then I'm going to use the table function on the graph button to get me a table of values. Start at 0 or start at 1, whatever's the default. And I'm just going to scroll down until I see it getting bigger than 75,000, which is the number in the question. So when you do that, you get something that looks like this. And you can see here that when n is 13, this one, oh dear, then the number's smaller than 75,000. For the next one, 14, it's bigger than 75,000, which means that n must be bigger than or equal to 14, so the smallest value of n that works is 14. That's the best way to do it. I'm going to show you the algebraic method for completeness. Actually, I'll do that on a new slide. So the algebraic method would be to set up this equation, 0.64, same equation we had, well, inequality strictly speaking, over 1.5 is greater than 75,000. And then we're trying to isolate n. So we'll do that, multiply both sides by 1.5. And you get 0.64 times 2.5 to the n minus 1 is greater than 112,500. Divide both sides by 0.64 and it's going to get bigger again. And you get the answer 175,781. So we've got 2.5 to the n minus 1 is greater than 175,781.25. If you were doing this, I wouldn't expect you, if you're doing it this way, I wouldn't expect you to write down all the digits. But I'm going to do it now. Add 1 to both sides, 2.5 to the n is greater than 175,782.25. And then to bring the n down, you want to take logs. I will use log base 10. You could go straight to doing it with log base 2.5. And you would get this, so I'd get n log 2.5 is greater than log of 175,782.25. You know what, actually, I'm going to scratch that. That's me being old-fashioned there. From the days where I wouldn't have been able to do log 2.5. So let's do it as people would do it in the 21st century. Log of base 2.5 on both sides. So we take logs of both sides and I get n is greater than or equal to 13.18. Now, I've been careful here to maintain my inequality signs the whole way through. And the reason for that is a lot of people get to this stage and think, 13.18, that's close to 13, therefore that's the answer. But that's not the case, because 13 isn't bigger than 13.18. What's the smallest number that is? Well, n has to be a whole number because it's the number of terms in a sequence. So, n is 14, and that's our answer.